Well, welcome. In this video lecture, we are looking at the book Think Python, How to Think Like a Computer Scientist. We're looking at the second edition. The authors are Alan, Jeffrey, and Chris. I'm going to be doing video lectures. My name is Arthur Solomon. I'm going to be working with you throughout these videos. Thank you. Welcome. In Chapter 5, we're looking at conditions and recursions. The objectives is we're going to look at built-in functions in Python. We're going to be exploring different forms of expression. We're going to examine operators, both relational and logical. We're going to review different forms of code execution. We're going to be examining conditional statements, looking at recursion statements, and lastly, we're going to be looking at and constructing stack diagrams. So all of this is kind of a build-up from the previous chapters. So first of all, the floor division and modulus. The floor division operator, basically two slashes, they will divide a number and round down to an integer. So for example, if we divide minutes, let's say we set them to 105, and we set hours equal to minutes, and we divide minutes by 60, that will give us 1. Because again, we're not really dividing, we're using the double slash, which is divide and round down. Alright, so I went ahead, opened up my machine with Python. I'm going to get Python open. Alright, so I want to go ahead and do minutes equal 105, hours equal minutes, double slash 60, and I'm going to go ahead and print my hours. So I get 1. The problem with that is, if we do some simple math, we know that 105 minutes divided by 60 is pretty much an hour and 45 minutes, or 1 hour and 3/4. So why are we getting it to round down? Well, that's the issue, is with our floor division modulus, it rounds down to the nearest integer. If we want to see the remainder, we can use the modulus operator, or the print sign. So again, here we're looking at the floor division being our two slashes, and our modulus operator being our remainders. So I'm going to go ahead and do the same thing. I'm going to go ahead and do remainder is equal to minutes %sign 60 remainder, and I should get back my 45 minutes. So it's a combination of 105 is actually 1 hour 45 minutes. It's not so much just one, it's a combination of them. So when we're looking at this, we have to understand that this is giving us the whole function. This is giving us the decimal function, or the return function. Next, we have our Boolean statements. A Boolean is pretty much true or false. Is 1 equal to 1? Is 5 equal to 5? Is 5 equal to 6? Well, that's a false statement. So 5 equal 6, that's false. So it should return a false. The nice thing is, our true and false statements are special values that belong to what's known as a bool. They are not strings, they are a Boolean, yes or no. When we do other type of course content, like if I'm doing a database course, is there a value? Yes, no. It's not so much a string, yes or no, it is a Boolean, yes, no. So let's move on to our rational operators. Those are pretty straightforward. The first one is our double equal sign. This operator is one of the rational operators. It means equals. The common error is when we use a single equal sign instead of a double equal sign. Remember that equal sign is an assignment operator, and a double equal sign is a relational operator. So there is no such thing as equal than, or less than, or equals to, greater than. So we're going to be playing with those a little more. So here we have not equal. That is exclamation point equals. This is greater than, less than. So the order of this actually matters. You'll notice it is caret, then equal sign. There is no equals and caret. This does not exist. Just like if we are doing less than or equal to, there is no, again, that does not exist. So the order that we write these actually matters. And these are relational operators. They're going to look at value A and value B, or value X, and compare it to value Y. Our logical operators are going to be things like and, or, and not. Examples: x equal, or x is greater than 0, and x is less than 10. This is true only if, again, x is greater than 0 and less than 10. So it's between 1 and 10. 10 not being a valid response because it has to be less than 10. So it's actually looking between 1 and up to the value of 9, but not exceeding. If we're looking at or, here we can be in modulus operator of 2 equals 0, or in modulus operator 3 equal to 0. This is only true if one or the other is actually true. If both of them are false, then it's false. Lastly, our last logical operator is not, and that is going to be, for example, not x greater than y is true if x is greater than y is false. That is, if x really is less than or equal to y. Essentially, we're looking for an opposite case. If this is true, we want the opposite. So we only may want to respond if not y, or not x. So as long as that is false, then we want that. Moving on, we have our conditional executions. And this is pretty much if something is set, do something. And you're going to start noticing we're going to be using if a lot more. The if statement have the same structure as functions. They have a definition, a header, and they have a compound called a compound statement. So what gets interesting here is we're using just our ifs. However, we can start saying that we're going to be doing more with those ifs. A compound statement is, again, that's the indented body of a function. So here we have an example of if returning a something, some type of value. We also have known as null or passes, and that is if x is set to something, you can set a pass. And again, a pass is just an ignored statement that breaks out of that loop. There is no limit to the number of statements that can appear in the body, and there has to be at least one. So occasionally, it is useful to have a body with no statement. So for that purpose, we use the placeholder pass, and that pass just basically says do nothing. Alternate execution, again going back to those ifs, is we can do if or something else. So you'll start seeing here we have if-else statements. So an else-if statement is also known as an alternative execution, and that is essentially if one statement, do this. Well, the do this is actually known as a branch. If something, first branch, else, second branch. Look at the indentation. The indentation is going to be important. Remember that the alternates are called branches because they are branching into other flows of execution. Again, this is known as an alternate execution in Python. We can do what's called a chain condition. And sometimes it's more than just two possible possibilities, and we need more than two branches. So one way to do this is called a chain condition. We can see that we can do an elif. That's just the abbreviation from else if. Again, exactly one branch will run. There is no limit to the number of else if statements that can cause. However, one of these statements will run. At the very end, we can have a else. If there is an else clause, there has to be at least one end, but there doesn't have to be one. Each condition is checked in order. If the first false, then the next is checked, and so forth until they find the appropriate correct statement, and then they will run that branch. So here is the example that I've given. If x is less than y, print content. Else if x is greater than y, print something. Else, print x and y are equal. So those are three different branches. Is x greater? Is y greater? Otherwise, they're equal. So a nested condition is essentially a if statement that pours into an else statement that then nests an additional if statement. So if x equals y, then they're equal. Or else in this example, if x is less than y, else x is greater than y. Those are called nested conditions. However, remember that the indentation becomes extremely important because the indentation of a statement makes the structure apparently nested conditional, and they become more difficult to read very quickly. It is always a good idea to avoid them when you can. However, sometimes it is necessary. Here we can see a nested conditions using logical operators. If 0 is less than x, if x is less than 10, then we can print something. Well, that allows us to verify a single-digit number. Another example is if 0 is less than x and x is less than 10, print, again, single-digit number. Or a third example, this is going to use a combination of logical operators. If 0 less than x less than 10. Essentially what we did there is we combined example 1 and example 2. Instead of having multiple or a logical operator like AND, we just combined all of them into a single statement. If 0 less than x less than 10, then print the response. If x is not less than 10, then that branch will not run. So let's talk about recursion. Recursion is going to be when the function can call itself. Remember, it is legal for one function to call another function. It is also legal for a function to call itself. It may not be obvious why that's a good thing, but it turns out that sometimes this can actually be a good thing. Here we're going to be doing an example of a blast off. We want to do a countdown and then do our blast off. So this is an example of recursion. We're going to do an if statement, and we're going to print as long as n is equal to or less than 0, it's going to print blast off. Else, it's going to print the number. Then it's going to do a countdown with that number. And again, you'll notice that the function is called countdown. So we're going to call itself, and we're going to run through this. So let's go ahead. I'm going to put this in Python and code it. All right, so I'm going to go ahead and set up my function. So I'm going to do countdown. I'm going to have the variable in. Oh, And I forgot, I have to make sure to do my colon at the end. From there, I'm going to do an if statement. So if n is greater than or equal to 0, colon, print blast off. Notice when I hit enter, I'm still tabbed with the print. I need to go back 1. Else, I want to go ahead and print the number. And I also want to do a call for that function. So countdown is now equals to n minus 1. So I went ahead and I ended that function. So what happens when I call the function countdown and I do a number of 3? Well, it's going to call the program if n is 1 or n is less than or equal to 0. It is not going to count down. It's going to print this blast off. Because the first iteration is 3, it's going to count back by 1. It will print 3, then it will do n minus 1, and then it will do this function again. The next time will be 2, then it will be 1. Then eventually it will get to 0, and it will print blast off. But you'll notice, first of all, there is some errors. I always do this. I did a capital P greater to or equal to 0. From there, I will print blast off. Else, I will print in, and I will do countdown. I make sure to spell it correct. Countdown n minus 1. And now I'll do my countdown. With 3, and that it actually works. Yeah, I did the capital P right there instead of lowercase p by accident. I also meant to say blast off, not blast dog. But if we do this again, countdown, and we give it a number 5, it goes 5 and it'll count down. Countdown 100, and then it will. Well, we could modify this a little bit, so maybe we want it to be greater than, we want the number to be, the n to be less than 10, for example, and we want to do a countdown from 10 to 0, or let the user input the number, however, check it to make sure it's at a certain range. That way we don't have these large ass numbers being put in here. It really just depends on, again, what are we trying to do and what is the process. So again, we've already seen that this is the function. We did a countdown of 3. So it did it once and it called itself. It did it second time and it's called itself. It did it a third time and it's called itself. And then the fourth time it ran, n was actually 0, so it didn't do another countdown. It actually went ahead and did our blast off. Other loops, while they do exist, they are not just as recursive as if loops. An if statement is not technically a loop, it's a statement, but there's a lot of content here. So this extra execution of a countdown, again, begins with 3. We do a decrement of 1 each time the recursion goes through. And we can actually do a stack diagram that denotes that. And a stack diagram basically is just the main function call, and then we do a countdown, and we set our variables. And this way, we can represent each step or each process all the way through. So we're going to start using these stack diagrams in other chapters. All right, so one of the important parts is as we go through the main and we see our 4 countdowns, the 4 countdown frames have different values for the parameter in as each time the loop is ran. The bottom of the stack, where in is 0, is called the base case. It does not make a recursive call, so there is no more frames. So this is how we can define and graphically represent our recursive calls. It's important to know that this last frame, this guy right down here, this guy, is known as the base case. Issue is, if we incorrectly do our function calls, we can have what's known as an infinite recursion, and that is where it never reaches its base case. It just keeps running. So if the recursion keeps making recursive calls forever, the program will never terminate, and that's a bad thing. We also have the ability to capture inputs. When we're capturing input, you're going to notice, first of all, the /in is a special character to denote a new line. So here is a basic, pretty built-in function that says do something. So the built-in function that stops the program and waits for the users to enter input is input. That way, it will pause the program and wait. So the program we've written so far have accepted no inputs from the user. For the most part, we've done some side examples where we will accept user from the input. Python provides a built-in function called input that stops and waits for a program. It's like a pause waiting for input. Before getting an input from the user, it's always a good idea to print a prompt so the user knows what they're supposed to be inputting. Lastly is our debugging. In general, error messages will indicate what the problem is. So when we start getting through our examples and exercises, look at the error messages. In our example earlier, invalid syntax, that let us know that this red area is where the error message is. I forgot the colon. When I did my call function, it actually let you know file in this module countdown 3, line 5 in the countdown print in. So I was able to do 1, 2, 3, 4, 5 lines. So that meant the issue was on the 5th line. And it even gave the name of the error. The name print is not defined. Print being capital P instead of lowercase p. That's the importance of being able to debug. We're only doing maybe 5 to 20-ish lines of code in these simple programs, and so that's okay, it's easier to debug. But when you start getting into like a multi-hundred thousand, tens of thousand lines of code, this makes it a little bit harder to decode. For our key terms, we looked at things like floor division, modulus operator, booleans, conditions, recursions, base case. You're going to have to remember base case because that's going to keep popping up. We have 6 exercises in this chapter. I'm going to be waiting to do videos on these exercises, but eventually they will be posted. If you have any questions, definitely feel free to reach out. That concludes this chapter. If you have any questions or concerns, please feel free to reach out and leave me a comment or a question. I'll try to get those answered as quickly as I can. Again, thank you, and I look forward to working with you in later modules.